Hey, sixth graders, let's talk about the transformation of energy, which is the last lesson in our energy unit. So far, what we already know is potential and kinetic energy. We know that potential energy is based on position. So for example, up here with this rock, what could possibly go wrong? Because it's really high up, we know that it has the potential to do something. Kinetic, on the other hand, is when it's moving. We also know that potential and kinetic energy depends on mass. The bigger the object, the more potential it has, and the more kinetic then it can have. We also know that gravity is the force behind the potential and kinetic energy, at least in the experiments that we've done. So for example, here we have two skiers with the same amount of weight, but the blue one is going to have more potential energy, which will then give it more kinetic once they start moving because they're at a greater height. Gravity can pull more on him. We've also learned about friction. Friction is the force that opposes movement. What forces things to not move? The more ridges or the rougher the object is, the more friction it has. And all objects have friction. Even smooth objects like a soccer ball, if you zoom in, you'll notice that it is actually textured. If we could zoom in on all objects really closely, we would see something like this. The rougher, the more friction, and the more that it slows objects down, which you saw with the ramps when you rolled objects onto different types of flooring. You probably noticed that the rougher the flooring, like carpet, the object slowed down a lot more versus on something like a tile with way less friction because it's smoother. We also know that when objects rub together, they get warm. So when you rub your hands together, eventually they'll heat up. That heat is called thermal energy and is the third type of energy that we're going to focus on. In this week's experiments, we're going to look at how does energy go from one type to the other. That's called transformation of energy. So for example, here we've got a person pedaling a bike. That's kinetic energy, they're moving. And he's lighting up this light bulb, which is electrical energy. It's going from one form to another. This happens all the time in our daily life. It'd be really hard to do stuff if energy couldn't go from one form to another. For example, I couldn't eat my toast if I couldn't get electrical energy into heat and kinetic energy in order to warm up my toast and pop it up. So as you go through the experiments this week, be paying attention to how do we go from potential to kinetic to thermal energy and back and forth between them. So be thinking, okay, this object is sitting still, or this object is moving. What's happening there? Does it change based on what this experiment is doing? That's the focus, because what you'll see, we've done a lot of already. So the ideas that you're going to see aren't new. It's more about the transformation of this energy. So I'm going to go through the directions now. If you are using the suggested schedule on our doc, then this is a good spot to pause because this would be the intro section. And then you can always click on it tomorrow and fast forward to this part and listen to the experiments directions for 1 and 2. So you've already done the intro. We are going to make our last ramp. This time, we'd like the ramp to have a track on it. That way, the objects will always go down the ramp the same way, and they can hit another object. So you're going to have a large object and a small object. We'd like the object to roll down the ramp and be able to hit the other one. And how you set that up is up to you. We've used rulers here. You could use pencils, paint sticks, a butter knife, anything that could help the object go straight. And then we'd like you to try these scenarios. So you're going to have a large object and a small. You're going to put the large object on the ramp and the small just sitting on the ground at the bottom. And then let the large object roll down into it. What happens? Move it up higher, move it down lower, and see what happens. That information is going to go in this chart here. Then switch them. Put the small object as the rolling one and let it just hit the large object sitting at the bottom. What happens? Now be thinking again, remember, This is sitting still, that's potential energy. This is moving, that would be kinetic. What happens when they hit? Do I have any transformation of energy? That's what you're thinking about here. In the chart, it's simple recording, nothing too specific, just large or small, describe roughly what was happening, high up, low down, just enough to remind yourself, and then a simple description of what happened. We've included some supplementary options for you. What would happen if you had different scenarios, and there's some listed here. You can even do it without a ramp. These all show transformation of energy, so I highly suggest that you try those, but they're just for fun. That would be experiment 1. It's a good spot to pause if that's all you're going to do today, and then come back to this video for tomorrow. So experiment 2 is virtual. We're going to use this website, which has been made specifically to show the transformation of energy. All the instructions on how to set up are here. We're going to be paying special attention to the bar graph as the skater moves and filling in the chart about what we notice. So it asked me to go to the intro, setting up my bar and my speed graphs. As you put your little skater person up here, you'll notice that the graph changes. This is what we're paying attention to. Total energy means how much energy do we have right now. And you're going to notice that these other bars change. Pay special attention. This is the skater moving down. This is the skater moving up. That'll be important as you fill out your chart because it asks you to copy, is the potential energy going up, down, or staying the same when the skater moves up the hill. You'll probably have to let the skater go up and down the hill a couple times in order to notice that. But again, just copy paste these 3 options into those charts. And then fill out the couple conclusion questions. Then we're going to add in friction. Going back to the home button, clicking on friction. I'm turning on my bar graph and the speed. I'm going to let the skater go, and you're going to notice that I have more bars here. Pay special attention again to how those bars change and be filling in. Does it go up, down, or stay the same for each of these situations? And then fill in the conclusion questions. Then come back and watch the second mini lesson to see if you've learned what you should have learned. And then we've got a few conclusion questions at the end, and we will be done with energy. Thanks for watching. Let us know if you have questions. We realize that this experiment has a few more steps than our experiments in the past. So just let us know if you have any questions. Good luck. Happy experimenting.